Today we're going to talk about how to graph from slope-intercept form. So if you would please set up your notebook. You should already have, let's go ahead and set up our notebook. Okay, so when we graph from slope-intercept form, so first of all, you should be familiar from last year with slope-intercept form. And I'm just going to remind you that the m in the equation stands for the slope. The b stands for the y-intercept. And then x and y stand for points on the line. It can be any points on the line. Okay? Now, just to start off real easy to make sure we know what we're identifying, I want to identify the slope and the y-intercept of each line. If you think you know, pause the video and write it down and then turn it back on and check and see if you're correct. So in our first equation, the m, remember the m is always married to the x, so the slope is 4, the y-intercept is -2. Simple as that. And the second one, the slope is -0.5. The y-intercept is 3. Remember, the y-intercept is the constant, the part that's being added or subtracted on. And the next one, our slope is 3. Notice there isn't anything added or subtracted on, so the y-intercept would be 0. And then here, this is turned around just a little bit, so make sure we're still recognizing what is attached to the x, the coefficient on the x. The slope is -2, the y-intercept is 5. Now, if we have an equation that is not in slope-intercept form, and we want to graph it with slope-intercept form, then we must rearrange the equation. Okay? So in this particular equation, our goal is to get y by itself. So we would subtract 8x, so this kind of goes back to how we worked with literal equations. So this would be 4y equals, and to truly keep it in slope-intercept form, I'm going to put the -8x first, but it would be okay if you wrote it 12 minus 8x as well. And then we have to divide everything by 4. So this would be y equals -2x plus 3. Now it's in slope-intercept form. Now we can say that the slope is -2 and the y-intercept is 3. You cannot identify the slope and the y-intercept just by looking at it if it is not in slope-intercept form. Okay, so that's really important. Okay, now as we start graphing, lots of different ways that you can do this, but I'm going to give you the suggestions that I always find are the easiest and the most effective. Okay, so to graph a positive slope, so first off, it's important to remember that a positive slope rises to the right. And so what I always tell my students, that if we have a positive slope, we're going to move up and right to start with. Up and right to start with. Remember, it's rise over run. And if it's positive, we want to go up and right to start with. If we have a negative sloped graph, remember it should be angled this way. It should fall to the right. And so what I tell my students on this one is if you have a negative slope, and it doesn't matter where the negative sign is, you want to move down and right. I always recommend to go right to start with if you have room on your graph. And that way all you have to think about is, do we move up or down? If we have an equation that represents a horizontal line, so first of all, a horizontal line will be y equals a number. Something like maybe y equals 3. And that's how you know it's going to be a horizontal line. And then if it's going to be a vertical line, then the equation is going to be x equals a number, like x equals -2. That's what the equation might look like. So these are, the bottom two are two special equations that don't really follow the rules of slope. We don't really identify the slope. Here on our horizontal line, our slope would be 0. In a vertical line, our slope would be undefined or no slope. Okay? Okay, so in our first, let's look at our first example. So the first thing we want to know is, what is our slope? Our slope is 3/5, and our y-intercept is 2. Now, the first point that we plot is the y-intercept. We begin with the y-intercept. Remember, y-intercept is where the graph crosses the y-axis. So I'm going to go up here where y is 2, and I'm going to put a point. And now my slope is 3/5. Remember, the top number tells us how our y's change, and our bottom number tells us how our x's change. So this is a +3, so we're going to move up 3 units, right 5 units. So from my y-intercept, I need to put my glasses on. I'm going to go up 3, right 5. 1, 2, 3, 4, 5. And I'm going to put a point. And then I'm going to do it again. I'm getting my glasses so I can see a little better because I have this reduced down a little bit. Ooh, that makes it a little better. Ooh, it does. Okay, so then if I think I have enough room, I'm going to go ahead and make another point. I'm going to go up 3, 1, 2, 3, right 5. 1, 2, 3, 4, 5. Now, once you get your graph going to the right, then you can reverse it. So I'm going to go back to my y-intercept, and now I'm going to move down and left. 1, 2, 3, 1, 2, 3, 4, 5. And you want to draw at least 3 points if you can fit it on your graph, because any 2 points can make a straight line. We knew this was a positive slope, so one way to check ourselves is, did we draw a positive sloped graph? And we did. Okay? Okay, let's look at the next one. Again, we want to identify the slope and the y-intercept. The slope is -2. The y-intercept is 5. So remember, we begin with the y-intercept of 5. So I'm going to go to my y-axis. 1, 2, 3, 4. Count up to where y is 5, and I'm going to put a point. Now my slope is -2. It's not a fraction. To make it a fraction, all we have to do is put it over 1. Okay? And then remember, I told you, if it's a negative slope, we're going to move down. So the -2 tells me to move down 2, and the 1 tells me to move right 1. So from my y-intercept, I'm going to go down 2, right 1, and put a point. Down 2, right 1. And I could keep going in that pattern to my right. Now if I want to reverse it, I'm going to go up 2, left 1. And there I have the slope of my negative graph. Okay, let's look at this example here. So this example is not in slope-intercept form. So the first thing we need to do is put it in slope-intercept form, which means I need to get y by itself. So I'm going to say minus x. So I have -2y, and let's go ahead and move the x in front. -x minus 3, and then I need to divide everything by -2. Okay? And so this is going to be y equals, now this is a little tricky here. This is a -1. -1 over -2 is +1/2. You need to keep that as a fraction, not a decimal, because that's slope, and we need to know how many to move up and down and left and right. And then plus 1.5 or 1.5. Now normally I don't give you decimals like that to graph, but I think this one is doable. We can manage this. Okay, so again, my slope is +1/2. My y-intercept is 1.5. So I'm going to go on my graph where y is 1.5, so just halfway in between. And now my slope of 1/2 tells me to move up 1, right 2. So here I'm going to go up 1, right 2, and put a point. So see, I moved just halfway in between. Up 1, right 2, and put a point. And once you get your graph going to the right, then you can reverse it. Then you can go down 1, left 2. Down 1, left 2. And now I have my positive sloped graph. Okay, the last one, again, this is not in slope-intercept form, so we do want to get y by itself here, so I'm going to subtract x. So this is simply going to be y equals negative x. My slope is negative 1. The y-intercept is 0. Okay, so I'm going to put a point where y is 0, right there. My slope is negative 1 over 1, so that, remember, means down and right. Down 1, right 1. Down 1, right 1. Down 1, right 1. Or up 1 and left 1. And there is my graph. Okay, last two equations. So we have two special ones here. We have x equals 4. So one thing to think about is this means x equals 4. So let's go find where x is 4. 1, 2, 3, 4. And then put a straight line through it. Just like that. That's a vertical line. Okay. Y equals negative 6. Go where y is negative 6. 1, 2, 3, 4, 5, 6. Draw a line through it. Okay, those are two special graphs. Now the last thing I want to mention is I want to talk about what's the whole point of graphing these. So the point of graphing it is that the graph is a representation. The graph represents all the possible solutions to the equation. That's the whole point of graphing it, is so that we can represent, it's just a different way to represent the solutions. So every single ordered pair on this line is a solution to the equation that I originally asked you to graph. Every single point, any point that you found on this line would be a solution to that equation.